Right. Weekly paper number 13. Question number 1. Question number 1. Given that fx given fx is equal to x squared minus bx plus 1. Here b is a real number. Right. First question asking write the discriminant fx equals 0. Right. Fx equals 0 mean is fx, no? Right. X squared minus bx plus 1 equals 0. Discriminant delta, right? X coefficient is the b, its perfect square minus 4 times a is 1, c also 1. Delta is this b squared minus 4. Right. Hence find the range of values of b such that fx equals 0 has real roots. For real roots, you know, for real roots, we know delta should be greater than or equal to 0. Delta is this, b squared minus 4 greater than or equal to 0. B minus 2, b plus 2 are the factors greater than or equal to 0. Now we can find the range. Here b2, here b minus 2. Here we have equal sign, therefore we select these two values. You know, when we put 0 for this b minus 4 coming to left, greater than 0 is wrong. Therefore this region does not satisfy. This should satisfy. This should satisfy. Then b takes values from minus infinity up to minus 2, including minus 2, and including 2 up to plus infinity. So therefore we can write the solution. B less than or equal to minus 2 greater than minus infinity, or b greater than or equal to less than plus infinity. Right. Number 2, second part. Let the roots of fx equals 0 be alpha beta. That means this is the fx. Its roots are given as alpha beta. Then you can write sum of the roots, product of the roots. Sum of the roots going to be minus x coefficient, then b divided by x squared coefficient 1. Here 1. Okay. Right. Show that alpha times alpha plus 1, alpha times alpha plus 1 plus beta times beta plus 1. Asking to show. Here we'll remove the bracket, alpha 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 squared, beta 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 squared. Here we get alpha, here we get beta, alpha plus beta. Right? This alpha squared plus beta squared we can write as alpha plus beta perfect squared minus 2 alpha beta. Right? Plus alpha plus beta. For this alpha plus beta, we can put b, here b squared minus 2 times alpha beta is 1 plus alpha plus beta is b. Then here we get b squared plus b minus 2. Show that the quadratic equation having alpha times alpha plus 1 and beta times beta plus 1 as roots. Right. The quadratic equation I can write this way. The two roots given are product beta times beta plus 1 product. Okay, the two roots. So then when the two roots are given, equation we can write x squared within first bracket the sum of the roots product of the roots alpha plus 1 beta, beta plus 1 equals 0. Alpha plus 1 part plus beta, beta plus 1. This one we know here. Put that way here. X squared minus b squared plus b minus 2 times x. Now we have simplified that. Here beta. Then this and this we have to open the bracket. Alpha and beta. Alpha and 1 alpha. 1 and beta beta. Right. Okay, now we can substitute there. Alpha beta product is 1. Right. P alpha beta 1 is alpha plus beta. This sum is P plus 1 is equal to 0. Then here we get x squared minus b squared plus b minus 2 times x, b plus 2 equals 0 is the required quadratic equation. Okay, next one asking whether used in suitable substitute transformation, deduce that quadratic equation having alpha times alpha plus beta plus 1, beta times alpha plus beta plus 1 as roots is this. Yes. Then the two roots are given. One is alpha times alpha plus beta plus 1. Other root is beta times alpha plus beta plus 1. Okay. So now these two roots are symmetric. Reason, if we interchange alpha and beta take in one root, the other root come in. So therefore the two roots are symmetric. So therefore that occasion we know we take any root out of these two as y. Right? Okay. Now what I do next is this alpha plus beta I multiply by alpha this way. Yeah, the earlier bracket, yeah, no, this way we can multiply. We multiply this way. Y equals this alpha and plus 1 I multiply by alpha first. This way. Okay, then alpha and beta I multiply next. Right. Now this alpha beta is 1. Put that way here. Bring that to this side. We get y minus 1. Alpha times alpha plus 1. Therefore, alpha times alpha plus 1 is equal to y minus 1. Okay. Then we can substitute this y minus 1. We know this alpha times alpha plus 1 is the root of this equation. Right. So therefore, alpha times alpha plus 1 should satisfy this equation. That means when you put for this x alpha times alpha plus 1 here and here, the left hand side will be equal to right hand side 0. That means alpha times alpha plus 1 means y minus 1. Therefore, we'll put y minus 1 here. Okay. Then we get in terms of y the required quadratic equation. Finally, that y we convert to x. Right. Then we get our required quadratic equation. Right. Now we can take the last answer. Since alpha times alpha plus 1 is the root of the equation above, we can put alpha times alpha plus 1 here for x and this 6, but that is equal to y minus 1. Then we can put y minus 1 for the place of x, right? So y minus 1 of x squared minus b squared plus b minus 2 times x is y minus 1, right, plus b plus 2 equals 0. Okay, now we can simplify this until we get this equation. We'll square this y squared minus 2y plus 1 minus b squared plus b minus 2 y minus 1 plus b plus 2 equals 0. Right, now y terms we can take together, y squared terms we can take separately. Right, so now here we have minus 2y, here we have, when you remove the bracket, y and this with minus sign, minus 5 we can take out, minus sign I put here, y here, minus y when you put here we get 2, minus and y we get this. Right, and now we have to take constant terms. Here we have plus 1, here minus and minus make plus, this part, b squared plus b minus 2, and here b plus 2 equals 0. Right, then we can cancel down this and this. We get y squared, take this b out, b plus 1y, this 2 you can cancel down. Then we get b squared, b and b 2b plus 1 equals 0, no? Okay, now we can convert this y to x, right? Though you keep like that in terms of y, it's still correct, okay? So we'll write for yx, then x squared minus, b times b plus 1 times x. This is nothing but b plus 1 squared, right? So this is the required quadratic equation, right? That's okay. Right, question number 2. Okay, number 2 is if x given two x cube plus ax squared plus bx minus 6, right? There we are given a, b real numbers. X minus 1, x minus 2 are factors of fx are. X minus 1 factor of fx means f1 0. X minus 2 factors means f2 0. I show that a minus 9, b 13. F1 mean put x equals 1, then this one should be equal to 0. 2 into 1 cube a 1 squared b into 1 minus 6 0. Here a, here b, here 2, here minus 6 minus 4 to take right hand side plus 4. Put x equals 2 here, 2 to the power 3, a 2 squared, b 2 minus 6 should also be 0. Here 4a 2b, 8 into 16 minus 6, 10, then that is equal to minus 10, take into right hand side. Right. Now, when you solve this, really we can divide this by 2, divisible by 2, no? 2a plus b minus 4, this is number 2. So, we can take 2 minus 1, b and b we can cancel down, 2a minus a is a, minus 5 minus 4 is minus 9, a minus 9. When a minus 9, take us right hand side, b 13. B 13, right. Okay, next part. For these values of a and b, express fx as a product of linear factors, right? Okay. Now I can substitute for a and b, and we can write fx. Fx is equal to 2x cube, simple a minus 9, 9x squared, b 13x minus 6. Asking to write the express this in terms of linear factors. Okay, now already this fx has two factors given in the question, x minus 1 and x minus 2. So therefore, I can write here 2x cube minus 9x squared, 13x minus 6. Two factors already we know. We can write x minus 1 is the first factor, other one is x minus 2. So next factor should be a first degree factor, because the degree of the fx is 3, here degree 1, here degree 1 of the first two factors. Then the third factor should be of degree really 1. So that should be ax plus b. So x should be there, but left hand side x cube coefficient is 2. From the right hand side, that x cube is given by a product of this into this into this. So therefore there should be 2 here, then only the product of this 3 will give 2x cube. And the other one I will take as k. That k here this constant is given by people the product of the constants available in the brackets. So therefore this minus 1, this minus 2, this will give the product minus 6. So therefore here, since we have here plus 2, this should definitely be minus 3. Then only this 3 will give this minus 6. So therefore the third factor is 2x minus 3. Okay. Right, now what is next asking? Hence find the quotient and remainder when fx is divided by this. Right. Now what I do, we know this is our fx, no? Our fx we write. I first take that 2x minus 3 here, right? And these two brackets we have, right? That two brackets I multiply, x and x squared, minus x 2x minus 3x, right? And plus 2. Now fx 2x minus 3, we complete the square of this. You know, steps in complete the square. From x squared we take only x, minus x coefficient we divide by 2. And this plus 2 we write, and finally we subtract all this what people? Perfect square of the number, second number in the bracket. 3 by 2 perfect square is 9 by 4. Right. Now we can write fx 2x minus 3 here, x minus 3 by 2 perfect squared. Here 8 minus 9 is minus 1 over 4. Then we will multiply by this the both. Then we get x minus 3 by 2 perfect squared into 2x minus 3 Okay, and minus 1 over 4 2x minus 3. And now you can very easily determine by this, when fx is divided by this divides quotient is this, remain is this, right? Therefore, the quotient is 2x minus 3. The remainder is that minus 1 upon 4, right? 2x minus 3. This way, we can take that answer. Okay, third question, trigonometry part. Write down sin A plus B. Expansion of sin A plus B asking. You know sin A plus B is sin A cos B plus cos A sin B, no? Right. Secondly asking, hence write down cos A plus B. Right. So, we substitute for here A, we replace this A by pi by 2 plus A. Okay. Then we get sin pi by 2 plus A plus B. Right. Right hand side, for A we put pi by 2 plus A cos B cos pi by 2 plus A sin B. Here, when I take this A plus B together like this is of the form now sin 90 plus theta. Sin 90 plus theta we know cos theta, therefore it is cos A plus B. Cos A plus B. Here sin 90 plus A, it's cos A and cos B. Here cos 90 plus A, cos 90 plus A is minus sin A. That minus and this plus makes minus sin A sin B. Okay. This way we get cos A plus B. By substituting suitable values for A and B, find sin 2 theta and cos 2 theta in terms of theta, right? So, we substitute in this and in this both A theta, B theta, right? Put in A equals theta, B equals theta in above formulae. What do you get? Theta plus theta is 2 theta. We get sin 2 theta. Here sin theta cos theta. Here cos theta sin theta. Cos theta sin theta, again you can write as sin theta cos theta. Here sin theta cos theta, here sin theta cos theta is 2 sin theta cos theta. Is the sin 2 theta. Okay, now here also we put A theta, B theta. Theta plus theta, 2 theta. Cos 2 theta. Here theta, here theta. cos square theta. Right? Here theta, sin squared theta. Right. Next one. Can you show that cos 3 theta? Yes. Now what we do next is, in this formula, we put A theta and B 2 theta. Right? Put A theta and B 2 theta in cos A plus B. Right. So what do you get there? When you put A theta, B 2 theta, theta plus 2 theta, 3 theta come in. Cos 3 theta. Right hand side, A theta, B 2 theta, cos theta, cos 2 theta, minus sin theta, sin 2 theta. Cos 3 theta, cos theta times, asking is cos 3 theta only in terms of cos theta. Right, first of all, should for this cos 2 theta by this answer, cos square theta minus sin square theta. Right, and here sin theta we have. Sin 2 theta, we can write 2 sin theta cos theta. Sin theta, right? And now cos 3 theta is equal to cos theta times here cos square theta, right, minus sin square theta I can write as 1 minus cos square theta, this sin square theta, and minus this 2 and this cos theta, sin square theta, that I write as 1 minus cos square theta. Okay. Now cos 3 theta we can write here minus and minus plus cos square theta plus cos square theta, 2 cos square theta, that we multiply with this cos theta, 2 cos cube theta. And now here we get minus 1 with this cos theta minus cos theta. Right. Now here minus 2 cos theta with this minus 2 cos theta, minus and this minus make plus 2 cos theta cos square theta is cos cube theta. 2 cos cube theta and over there 2 cos cube theta together 4 cos cube theta minus cos theta minus 2 cos theta minus 3 cos theta. This is the formula for cos 3 theta. Right. That also we got. Right. Okay, finally asking, using the results above, solve the equation cos 3 theta minus 4 cos 2 theta plus 2 cos theta minus 2 equals 0. Right. Let's see how to take that one. Okay. Okay, now the given equation is cos 3 theta minus cos 2 theta 2 cos theta minus 2 equals 0. For this cos 3 theta, I can substitute that 4 cos cube theta minus 3 cos theta, 4 cos cube theta minus 3 cos theta minus 4 cos 2 theta, I can write cos 2 theta, really we know cos square theta minus sin square theta. Here, I wrote here cos square theta minus sin square theta for this cos 2 theta. Inside the bracket, when you simplify, we get minus minus plus cos square theta 2 cos square theta minus 1, right? This is I can therefore write 2 cos square theta minus 1, right? And plus 2 cos theta minus 2 equals 0. This way you can write it. Okay, now when you simplify this, here we get 4 cos cube theta minus 8 cos square theta and minus 3 cos theta plus 2 cos theta is minus cos theta. Here plus 4, there minus 2, then 2. That way we get. Now I can take by this 2 4 cos square theta out as common factor. Then here we get cos theta minus 2. From here we can take minus sign out, minus 1 out, then cos theta minus 2, there also we get. Right now? Okay, now you can see here cos theta minus 2 common, right? And here we have 4 cos square theta minus 1 equals 0. But you know this is not equal to 0. Then there we get 4 cos square theta minus 1 equals 0. Cos square theta 104. Cos theta is plus 2 minus half. We get like this. Then we can write the two solutions. We'll first take cos theta equals half. Then this half you can write how? Cos pi by 3. Then theta equals 2 n pi plus 2 minus pi by 3. N is an integer. Secondly, cos theta minus half. Cos theta equals minus half is cos 120. Then theta equals 2 n pi plus or minus 2 pi by 3. N is an integer. You see, we can write it. Okay. That is the end of that question. Right. Question number 4. Limit question. Yes, given that limit x going to pi by 2 root 3 minus root 2 plus sin x pi by 2 minus 6 cos 6. Right. Now, first I multiply this numerator and denominator both by the conjugate of this. Okay. So, there we get limit x going to pi by 2 root 3 minus root 2 plus sin x root 3 plus 2 plus sin x. Pi by 2 minus 6 into cos x root 3 plus root 2 plus sin x. Right, this 2 you can write a squared minus b squared, right? You want to get root 3 squared 3 minus, when you square this root sign, people, you know the root sign will eliminate. So then there we get 3 minus within bracket 2 plus sin x. 3 minus 2 is 1, 1 minus sin x coming there, right? When you multiply these two. One minus sin x divided by pi by 2 minus x into cos x root 3 plus root 2 plus sin x. This is right. The next one, this one I can write as cos squared x by 2 plus sin squared x by 2. And that sin x I can write as 2 sin x by 2 into cos x by 2. This one I can write cos squared x by 2 plus sin squared x by 2. This one I can write 2 sin x by 2 into cos x by 2. This way. And here pi by 2 minus x. This cos x you can write using half angle formula, cos squared x by 2 minus sin squared x by 2. Right. Root 3 plus this 2 plus sin x. You see. You can very clearly notice here, this bracket we can write as cos x by 2 minus sin x by 2 perfect square, no? Limit x going to pi by 2. Numerator this bracket is cos x by 2 into sin x by 2 perfect square. Divided by pi by 2 minus x. This one I can factorize cos x by 2. That we can factorize as difference of two squares. Cos x by 2 minus sin x by 2 cos x by 2 plus sin x by 2. And in bracket root 3 plus root 2 plus sin x. This way. Then this factor you can cancel down with this. Okay. Right. Now next one. Limit x going to pi by 2. I divide inside the bracket by root 2 and multiply outside the bracket by root 2. This way. Root 2. Here 1 over root 2 cos x by 2. 1 over root 2 sin x by 2. Divided by pi by 2 minus x. Cos x by 2 plus sin x by 2. Root 3 plus root 2 plus sin x. Now, this 1 over root 2 I can write as sin pi by 4. Then this one I can write as cos pi by 4. Right. Limit x going to pi by 2, root 2 sin pi by 4 into cos x by 2 minus cos pi by 4 into sin x by 2 divided by, here I divide this and this both by 2, mean time multiply by 2. It won't change, no? 2 pi by, right? This we divide by 2, multiply by 2. This won't change, pi by 4. This we divide by 2, multiply by 2, x by 2. Right. Cos x by 2 plus sin x by 2, root 3 plus square root of 2 plus sin x. This is. Now, here you have sin A cos B minus cos A sin B form. That is sin A minus B. That is sin A minus B. Then we can write this root 2 divided by 2 is 1 over root 2 sin pi by 4 minus x by 2. Right? Divided by pi by 4 minus x by 2 here. Right. And next to that, we must write this and this. Then we get 1 upon cos x by 2 plus sin x by 2, right? And 1 over root 3 plus root 2 plus sin x. We have this. Okay, now, you know, here x going to pi by 2, then x divided by 2, half of x going to pi by 4, no? As x going to 90, half of x going to 45, correct, no? X going to 90, then dividing both sides by 2, x by 2 going to pi by 4, 45. So here, x going to 90 mean x divided by 2 going to pi by 4, correct, no? Then x divided by 2, this value gradually come into this pi by 4. Then this difference will be 0. If you take this pi by 4 minus x by 2 angle as theta, here we have sin theta divided by theta. But pi by 4 minus x by 2 going to 0 mean sin theta by theta as theta going to 0. This is therefore 1. Right? So therefore here we have 1 over root 2. This is 1. Now here and here I can put x going to pi by 2, no? Here when I put 4x pi by 2, here we get pi by 4, right? Pi by 4 cos pi by 4 is 1 over root 2. Sin pi by 4 also 1 over root 2, right? 1 over root 3 plus, right, sin pi by 2 x, then pi by 2. Sin pi by 2 is 1. Right. Then we can multiply here. Once I bring this root 2 here and here, root 2 by root 2 1, root 2 by root 2 is 1, 1 plus 1 is 2. 1 over 2 there. 1 over root 3 here plus root 3. Right. Then we get 1 and 1, 1, 2 into, this is 2 root 3. 2 and 2 make 4, 1 over 4 root 3 is the answer. Right? Okay.